random forest is one of the bagging techniques. What do we mean by bagging? So bagging means we create multiple decision trees and we take the answers from each one of the decision trees and then combine the answers. It can be explained better with a diagram. So over here, we look at a good diagram that I have created. Um, I think it's here. Yeah, in supervised machine learning. See, what random forest tries to do is it tries to create multiple decision trees. Okay, they are independent of each other. Like this decision tree does not know what's happening with decision tree 2. This decision tree does not know what's happening with this tree. Okay, but they are producing the results independently. And what we do, we take the average of these predictions and generate a final prediction. Now, on which data are we generating these? Now, on which data we are generating? So maybe let me first help you visualize this. Okay, let me share my notepad here. Hmm. So in the end, what happens in random forest is this. So random forest, essentially, let's say your target variable over here in this case study is what? Price. Yeah, this is the target. So what random forest will do, random forest will create multiple decision tree. Let's say it creates 3 decision trees. So decision tree 1, decision tree 2, decision tree 3. So the original price was 100, 150, 700, 800, 160, 180, let's say. Okay, so decision tree 1 is giving you the answer as the answer for this particular row is 110. Decision 2 tree 2 is saying the answer is 150. Decision tree 3 is saying the answer is 90. Okay, because they are built on different data sets. So the final answer that the random forest will give you is this. 100 plus 150 plus 90 divided by 3. So it will take the average of all 3 numbers and that will become the final answer for the random forest. So because random forest is a collection of decision tree. Why are we doing this? How is it helping me? So individual decision trees can be more accurate sometimes and can be less accurate sometimes. But if you combine the power of multiple decision trees put together, then the predictions that you will generate will be more reliable. So random forests, essentially, in the end, they help me to control the bias and the variance. So individual decision trees may be biased and they may have high variance. So this is controlled using random forest because I am considering the opinions or the answers from multiple decision trees. Okay. Now, if you take the data, full data, and draw multiple random samples. The key thing is drawing random sample. Okay, so let's say sample one also have this full data contains 500 rows and you created a sample of 400 rows, another 400 rows and another 400 rows. Okay, so you understand from random sampling that the rows that will get selected here versus the rows that will get selected here versus here, they will be different. If you take random samples, the rows that will get selected in each one of these will be different. There might be some common rows. Let's say row number 5 got selected here. It might be selected over here also. But if you take the whole combination, there will be some different kind of rows that will get selected in each sample. In machine learning, typically we do all the random samplings with replacement because otherwise we'll lose a lot of data. Yeah. Now, if on each one of them, if I create a decision tree model, this decision tree will look almost the same. The root node that I'm going to get, if let's say age is the best column in the data, then here also age will be the best column, here also age will be the best column, here also age will be the best column. Everywhere age will become the root node. So then there is no difference in the prediction. The prediction will be similar. Then what is random forest doing differently? Random forest is sampling rows as well as columns. That is the key thing to remember. This is exactly what makes a random forest different from creating multiple decision tree, because it's a common interview question that I ask and people get confused. Like if I take the data and I simply create 10 decision trees on top of it, will it be same as my random forest? It will not be. Because random forest also samples the columns. So that is something you can visualize it here. See in this good diagram. the step, sorry, the step one. So in this scenario, let's say the prediction that we are making is approval of loan based on the CIBIL score, the age, the salary, whether I approve the loan or not. Okay, it's a classification setting, but the concept remains the same. So what I do, I first take the training data. Let's say this 20 rows are there. I select the random rows from it. So here, let's say 3, 7, 9, 14, 19. These rows got selected. Here 4, 10, 13, 14, 17 got selected. Here 2, 5, 7. So see, this 7 is common in this one and this one. So with replacement. Here 14 is common. So some of the rows may be common in different random samples. So I'm selecting random rows and then I'm also selecting random columns. So if I give all of these columns to the decision trees, and if let's say salary is the best column or CIBIL is the best column, CIBIL will always form the root node. If the root node is same, then there is no difference in the predictions. It will always be same. So to break that monotony, what random forest did, it randomly selected the predictor columns also. So here you will see age and salary, then CIBIL and age, then CIBIL and salary. Okay, so it is randomly selecting the columns, but the target variable remains the same. Now on this data, if I make a decision tree, then let's say salary is a good, better column. So salary will be root node. On this data, salary is not present. So maybe age or CIBIL may be the root node. In this data, salary will be the root node, but CIBIL is present. So different angles are possible, different ways are possible in which I am doing my predictions or looking at the data. It is only possible because I am restricting the features. And then for each one of these different type of variables, I am creating my decision trees. And each decision tree is giving out its own opinion, its own result for every row. So for that, I am taking my final prediction by averaging it out.